And then I don't know if you notice in the videos, but my first like sentence is always cut off. Okay. So what we're looking at today is when we have a parent function and I add all those numbers to it. Okay. How does that change your function? And the word that we use is transformations. Okay. So we have various transformations. And so the way that I want to look at this is I've got a Desmos ready for us. I'm going to go to parent function. And folks, we have new letters. Do you see which letter is missing? H is missing. Okay, and what are the new letters? D and C. And K, you're going to hate this the most. The K is actually in a different position. And the K for a parabola used to be the vertical translation. It has now a completely different job. Okay, so pretend you know nothing about K. Okay, so so what I want to do with you is look at these letters and see how they affect the function. So, absolutely. Like that? Mustafa, you can see? Why don't you move? You can have a much better seat right here next to Angelina or Eli. Up to you. All right. So here we have a radical function. I like to use actually, maybe I'll change it to quadratic for now. Something that's familiar to us. So the first thing we're going to look at is the C. Any guesses? So actually, forget it. I'm just going to show you. So here I have the C, and I am going to just press play, and it's just oscillating between positive 10 and negative 10. So what's the word that we use for C? What's the name of it? Vertical translation. Is it changing the shape? Is it flipping it? Moving it sideways? No. All right. So let's make a note of that. So the C, does it change the shape? No. Do the X values change? Meaning, does it move to the left and right? No. Do the Y values change? Yes, right? Because the C moves the function up and down. Overall, how does the graph change? Okay. So this is what we call the vertical translation. And the only thing that happens, like as we said, the X's stay the same. We take the C and we add it to the Y. And I'm going to show you how I know that we add it. We know this from parabolas, but I'm going to stop you. So when I have a C of positive 10, like x squared plus 10, the vertex goes up to 10. And when I have a C value of negative 10, okay, I've got my vertex goes to negative 10, right? So this is what we used to call what? Which letter used to represent the vertical translation? The K. Okay, so this is just the K. Now, what if I change the function? What if instead of y equals x squared, I use the radical function? Well, let's see. As I move the C, what's happening to it? Just another vertical translation, right? The shape doesn't change. It doesn't move sideways. So all that C does, regardless of the function, is it moves our function up and down. What if I did the reciprocal function? It's just moving up and down. We see that? So that's what the C does. So let's get rid of the C. What's the next one we're looking at? D. Okay. And where is D in here? Okay, so notice the position of D. D is inside the bracket with the X. Any guesses? Make your parabola. Show me what you think this will do. Okay, that's the guess I see. Let's see. Let's press play. Isn't that so fun? Come on, this is like better than any movie. Okay, are you correct? What do we call this? Horizontal translation. Is the shape changing? Are the y values changing? Okay, excellent. So the D, does the shape change? No, it doesn't. Do the x values change? Yes, they do, right? Because we are moving left to right. Do the y values change? No, they don't. Right? We call this the horizontal translation. I'm just going to write horiz translation. Now, here's the thing. Similar to y plus c, any guesses what we're going to write? How does this change the function? If I wrote that a vertical translation, you take the y values and you add the c, take a guess, Greg. Okay, so Greg is saying x minus d, because remember when we have that parabola, we have to flip it. So I'm just going to write x and a d, and what we're going to do is we're going to look at what happens. So when my d value is positive 10, has it moved left or right? So have I added or subtracted the d value? Let's check what happens when I go into the negative. Am I adding or subtracting the d value? I'm still adding, right? It's like I'm adding negative 10 because my d is negative 10. So how is that? Have we been doing it wrong the whole time? And the answer is we have not been doing it wrong the whole time. It's just that we forget what the function notation is. When I write any function notation, i.e. like the formula, there is a minus inside that bracket. Let me go back to grade 10. When I wrote the general equation of a parabola, it was like this. So it was plus k, where it was minus an h. So if you had x minus 2 squared for your parabola, does this transformation make the parabola move left or right? Right. Okay. Now, what is the h value in this case? Is it 2 or negative 2? Let me help you out. See how this negative is here? That's part of the formula, meaning this negative is part of the formula. It is not part of the h. Okay, so what is the h value in this case? Positive, right? That's why this makes the parabola move 2 in the positive direction. It's not that it's doing opposite. It's just that we forget that the actual formula itself has a negative in there. Okay? So how does the horizontal translation affect it? Same way. It's x plus d. So whatever your d value is, whatever your horizontal translation is, you add it to the x values. Okay, let's bring in the a. Okay, so we're familiar with the a. This is the one thing that doesn't change. Okay, let's play a. Let's do a. Is this clear or is it unfamiliar? Let's change it to our quadratic that we're comfortable with. So when the a value is greater than 0, when it is positive, what does that mean? Show me with your hands or arms. Yeah, the parabola opens up. What if it's a negative a value? The parabola is inverted. Good. What if your value of a is greater than 1? Show me what that does. So we got a parent parabola greater than 1. It's a stretch. Less than 1, compression. What if your A value is -5? Show me with your arms. Am I narrow? Yeah, that's right. What if your A value is -0.5? Beautiful. So the A value tells us two pieces, right? It tells us this we call, watch this, this is a reflection, okay? In which axis is this being reflected? Love it, the x-axis, that's right. So think of the x-axis as a monkey bar, and think of the parabola as like a gymnast, and they're flipping over the x-axis. The shape is not changing, they're just reflecting in the x-axis. Could I do a reflection in the y-axis? What do I do physically? That's right. Now, does it matter for the parabola? No. So watch this. Because the parabola is perfectly symmetrical, we've never talked about a reflection in the y-axis because it's kind of pointless because it's identical. But which function could be reflected in the y-axis and not be identical? Show it to me. Show it. That's right. Right? So if you're like this and you reflect in the y-axis, is it different? Yes. Okay. So the A value, first of all, is just a reflection in the x-axis, and it tells us how if it's a stretch or a compression. Now let's go back and look at the radical function and just notice. So it does get reflected, and as we get closer to 10 and -10, you just notice that radical function is being stretched. Do you see that? Like it's still a radical function, but it's just it takes, like when we're here, it's just wider, right? Because it's stretched vertically. It is a vertical stretch. So does the shape change for A? Yep. Do the X values change? That's a bit of a tricky one to say, but I'm going to say no. Do the Y values, do the Y values change as we're stretching it up? Yes, right? That's kind of like with the parabola, we had the step pattern, and the step pattern made the Y values change. Okay, so we call this two things. We call this a vertical stretch. I'm just going to write vert stretch. And we call this a reflection, a vertical reflection. Actually, let's call it reflection in X. Reflection in X axis. Let me make the X more clear. I know we say reflection in X axis, but you might want to say reflection across the X axis. I don't know. And so what we're doing here, similar to the Y pattern, we're taking that A value and we're multiplying the Y. Yeah. Yes. Okay, here's another one, a new one. And this is the K value. So let me set A to 1 so that the shape is back to normal. I'm going to start off with the parabola and show you why we never learned the K. So if you knew nothing about the K, what would you tell me is changing? The A, right? You would just say, oh, that's a vertical stretch. And in fact, it is. And for a parabola, the vertical stretch and the horizontal stretch do the exact same thing. So we've actually been working on a combination of those. But let's see a function that can show the difference between a horizontal and vertical stretch. So a horizontal stretch, okay, so if I just work in the positives, here is my parent function. Watch what happens when I stretch it horizontally. it looks like a vertical stretch, right? This is actually a horizontal stretch. Now, actually, sorry, it's not a horizontal stretch. This is a horizontal compression. And let me show you what I mean. So if I look at the Y value, so at 1, so when I'm at a regular parent function, when x is 1, y is 1, right? When x is 4, y is 2. When x is 9, y is 3. Let's see what happens when I increase the k value. When I increase it twofold. Okay? So now, when does y equal 1? So this is at, no, y equals 1 actually at 1/2. When does y equal 2? Y equals 2 at 2. When did earlier y, we had a point right here. Let me show you this. Okay, perfect. So let's follow these points just so we could really see what's happening. In the original parent parabola, okay, I've got a y value of 2 when x is 4. Now that point of y of 2 has moved up here when I increased k to 2. So am I stretching this function or squashing it? You're squashing it, right? This black function becomes the blue by squashing it, right? I'm compressing it horizontally. Now vertically, this is the important thing. Vertically, it looks like I'm stretching it. So a vertical stretch can be equated to a horizontal compression. Can you visualize that? Okay. Now let's see what happens when my k value is negative. What would I call that? It's a reflection in which axis? The y-axis, instead of in which, around which axis? Around the y. It's like now the y-axis is my monkey bar, and I'm sort of doing like a horizontal flipperoochie. Okay? So this is what's new for us. So let's go to the k value. And does the shape change? Absolutely. Do the x values change? Yes, they did. The y values did not change. And so we call the k value a horizontal stretch, stretch, and a reflection. We say stretch as a stretch factor, but it can also be compressed. You could say horizontal stretch or horizontal compression. The wording gets weird with this. And a reflection in the y-axis. We're not going to do the last two columns because we kind of combined them into the column of A and K. And so in this case, any guesses what we're going to do here? What would be the quick formula to figure out how the k value affects the function? What's your initial guess? K times x, right? So that would mean, oh, when k is 2, that would mean my x values get stretched and get bigger. Yeah, but they didn't get bigger because remember they got squashed. So in fact, the k value affects the function in the opposite way that the a value does. So we divide the x values by the k. Yes. All right, let's summarize what we've just learned or what we've just looked into. So this is what we call function notation for all the transformations. What do you see here that's weird? Or like you're like, I don't like this. Which part of this do you not like? Double brackets. What else? What's in there that you're like, what do I do with that? Thank you. Do you see this? This means function of, right? It's just a function. And so if you have this type of function notation, you can figure out what the transformations are, but you have no idea which function we're talking about. You don't know if the parent function is a parabola. You don't know if it's a radical function or a reciprocal. But you could look at it and tell me what the transformations are. Okay, we'll get, like, I get this is weird. We're going to work with it and get more comfortable. All right, so let's do a summary of what we know thus far. Okay, we know the vertical stretch factor is A, and it stretches by a factor of A. Okay, so if A is 2, it's stretched times 2. How do we do it? We multiply all the y values by A. So I like to just write it like this, our summary. And if A is less than 0, there is a reflection in the x-axis. Easy. We know this one from last year. Okay, I like this. Now the new part is our k value. So finally, we are using something called a horizontal stretch. And we stretch it by a factor of 1 over k. Okay, so if the k value is big, that actually means we are squashing it. We are compressing it, right? So let's make a very simple. Big K equals compress horizontally. Small k equals a horizontal stretch. So this one is the one that's counterintuitive. I think at some point I will jump off the desk to remind you that it's 1 over k, not just k. And if k is negative, if it's less than 0, then there is a reflection in the y-axis. So once again, what would be sort of our formula? What happens to the x values? Well, the x values actually get divided by the k. Next, we have our horizontal translation, which formerly known as h, right, if that helps. Formerly, it was our h. And really, once we find the d value, we move it to the right or left. Recall, if you see x plus d, then that means the original d was negative, and we shift it to the right or left? Left. And so that's why we can say x plus d is how the function is affected. So notice that with the two x ones, we're doing the opposite of what we think. Do opposite. So anything related to x in the functions is always the opposite of what we would think to do. And then the last translation is the vertical translation, up or down. That is our c. If c is greater than 0, if c is less than 0, then we translate c units up or down, down. And so we write y plus c. Okay, so that's a bit of a summary of what we looked into. Note on transformations. When there's a combination of transformations, there's a stretch, there's a vertical, horizontal translation. Translations are always performed last. It's sort of like the order of operations. So when you have adding and multiplying, what do you do first? You multiply. So and the multiplication comes from the stretch and from the stretches. So the order of transformations goes R S T. Okay, so what's the first thing we do? We first reflect, then we stretch, then we translate. Okay, this is the order in which you will complete your transformations. Sometimes, yeah, it's alphabetical, isn't it nice? Sometimes when you get a function, you're not able to tell the transformations immediately. Sometimes we need to factor before we can identify the transformations. Okay. Also, when you are transforming, sometimes there's a point that isn't affected. Okay. Like if I have a radical function and it gets stretched vertically, this starting point doesn't change, right? It's still 0, 0. So we call that the invariant point, meaning it doesn't get transformed, it doesn't get affected by the transformations. Let's look at this example of a function with transformations, and I'll show you why the factoring part is important. So we're asked to describe the transformations in the correct order that would map a function with this notation. Okay, do you see where we can factor? What can we factor? We can factor out the -2. So you keep the f there, you factor out the -2, and so what we'll notice is it looks different and it affects our transformations differently. So let's describe them. Are there any reflections? So how would I know this? There is a reflection, and the way that I do this is I look at my A, K, D, and C. Okay, so maybe what I'll do, I'll look at these guys. Give me a second here because I'm. Yeah, we can do that. All right, folks, I'm going to change up the lesson a bit because I don't want to rush it too much. So for your homework, you're going to do 3 and 7 only. And unfortunately, we're going to move the function aerobics to Thursday. I know, I'm really sorry. But I just don't want to rush it. And I want this to be like, this is such an important part about functions. I want it to really be understood. That's okay. You can wear it 2 days in a row, or you can wear it on All right, but so we're going to do this page tomorrow, but I want to finish this page. Yes. So then, no, because I don't see you Friday. So the quiz, I'm going to have to move the quiz till the next week. Yeah. Yeah. So it kind of messes everything up, but I'd prefer to do that than have you folks be confused. Yeah. You check the schedule, right? Yeah.
I usually do.
Good. All right. So folks, wait. We're not done. Oh, you want, okay. So let's talk 30 seconds about the changes. So the changes are for homework. All you're going to do is question 3 and question 7. Okay. This is going to be day 1 of transformations. And quiz will be on Wednesday. No, quiz will be on Tuesday after the break.
Wednesday.
I'd be fine to start the new unit the day before.
It's not a unit.
I don't want the quiz on.
I don't even know if I'm allowed to give you on Tuesday. I'd prefer to give you a review period first half of Tuesday and then do the quiz second half of Tuesday. I mean, I can. It's not awesome, but
we could do more lessons.
Quiz on Wednesday. Okay. It probably because I think I'm not allowed to give you a quiz on Tuesday, after a long weekend. So it'll probably have to be on the Wednesday. It's not ideal, but such is life. All right. So that you know how to do your homework, let's break apart what this means. And in order to do that, we need to figure out for this given function, what is the a, what is the k, what is the d, what is the c. Okay, so I'm looking at this function notation. Now, once again, I don't know the shape of this function. All I know is I can describe how it's going to transform, but I can't actually draw it because I don't know. Is it a parabola? Is it radical? Is it a straight line? Is it a zigzag? I don't know those things. So let's look at the transformations because that's all we can do. What is the a value? So in order to find the a value, I look at the number that is in front of the f, the function symbol. What is the number in front of the function symbol? So good. Okay, do you see here there is no number? So we make a value of 1. So is there a vertical stretch? Is there a vertical reflection? No, because that would mean this number would be negative. Okay, let's look at the k value. So where do I find the k value? Well, the k value is in front of the x and not inside the bracket. What is the k value? -2. So what does that mean? Reflection in which axis? The y-axis. Excellent. Is the function going to be stretched or compressed horizontally? Yeah, it's going to be squashed. All right, let's look at the d value. Where is the d value, first of all? The d value is inside the bracket, right? And there has to be, and there's a minus that is part of that formula. So as a result, what is my d value here? -6. Beautiful. Okay, it's the opposite of what you see. So if you see +6, that means your d value is -6. And lastly, what is the k value? Sorry, what is the c value? -8. That's the one that is outside. Now we describe the order of transformations. And we do that by first stating the reflections. So there is one reflection, right? We said it's going to be a flip in the y-axis. So we say reflection in y-axis. or across y-axis or around the y-axis. Okay. Then we move on to the S, and that is a stretch. And when I say stretch, I mean, is there a stretch or a compression? Okay. So there's two ways to write this. You can say a horizontal stretch by a factor of, and I would actually, let's just do that. Horizontal stretch by factor of. Does anyone remember how we find it? Are we stretching by 2? No, because remember, anything to do with the x, it's going to be the opposite. So watch this. We're going to stretch by a factor of 1 over 2. Remember, that's the whole 1 over k thing. 1 over k. So when you stretch by half, you're actually making it, you're squashing it. Okay, so you could say it's a horizontal compression by a factor of a half, but I'm also okay if you always say it's a horizontal stretch and just give me the correct factor. Lastly, let's talk about the translations. So there are 2 translations. Okay, yes.
Why is not negative 1.5 too?
Okay, great question. Why am I not saying negative a half? Because the negative tells me there's a reflection, and I've already talked about the negative. Okay, so I first talk about the negatives, then I move over to the stretches. Okay, I'm really breaking it up. Translations, I've got 2. The order doesn't matter. It's like when we did BEDMAS, addition and subtraction, just whatever comes first. So the 6, show me in which direction the 6 is going to move your function. Good, in the left direction. So 6, and you can just use arrows. 6 left, and 8 in which direction? 8 down. So you don't need to use words here. You can just use arrows. But what's important here is you first describe the reflections, then the stretches, then the translations. Folks, this is what you're going to do for homework. Lastly, notice what would happen if we didn't common factor first. We would be screwed. Yes. What would it? You would have thought that it moves 12 to the right as opposed to 6 to the left. So always common factor first. Muntaha, you didn't hear the news.